the Laboratory, a video series brought to you by Miracles Innovation Labs.
Hello everybody, welcome back to Miracles Laboratory video series, brought to you by Miracles Innovation Labs. This is Aditya Chini and I work for Miracles Innovation Labs. Today I'm going to talk a bit about edge-based inventory management using Microsoft Custom Vision, like how the machine learning model is running on an edge device. So I'm going to talk about the advantages of machine learning running on an edge device as well. That being said, let's move on to the agenda. Today's agenda would be why machine learning model is running on edge, and a bit of introduction about custom vision, and then I'm going to talk about edge devices like CPUs, GPUs, and then TPUs slowly, how they were evolving slowly, and how they're actually helping us in terms of having your machine learning models running. TensorFlow Lite and OpenCV, the frameworks which are helping us to actually access these machine learning models and then have your application running. And there's a high-level architecture that we built for this demo, so you can actually understand what we're doing over here, and it explains you in a detail how the demo is actually flowing in. Right after that, we have a live demo, so which is an interesting part, like how the image is being classified and how the inventory is managed. So you're going to take that live demo and then and understand what we have done at Miracles Labs. So before going into the actual slides, I want to talk about Miracles Innovation Labs. So we are people of like 100+ researchers working on really cool technologies like Internet of Things, cognitive computing, next-gen, cloud computing, machine learning, and others. And we do have a RIPS process where we take challenges from our customers in order to build an end-to-end solution on these technologies. We also have a co-innovation model for pilots. That's where we work and deliver things to customers back. And we have our laboratory video series at miraclesoft.com/the-labs, where we've been posting our laboratory videos from across all the technologies that we have, and like there are already 50+ videos on the YouTube, and you can go and watch those videos and learn something from us. Edge computing and why the intelligence is moving slowly towards edge. So everybody are talking about edge computing, and so what's edge computing and what's the advantage of that? So basically, whenever you build a machine learning model, you have your model running on your cloud servers, which is like very high in powerful and high in processing. So that's where it takes a lot of amount and time and a lot of cost in terms of getting your models running properly. But when coming to edge computing, you can actually have your model running on your locally on your edge device, and you can process and get the data really quick. And machine learning models can run on the edge devices because it provides significantly faster predictions for critical IoT applications as well. Processing and analyzing data like images or videos will be really quick on your edge devices, because that doesn't rely on your network, because whenever you put your whenever you put your machine learning models, they're going to run on your edge devices. So that's where you don't really need a network or a bandwidth to actually go and get those model results from that. So that's where it gives you a faster analysis and faster processing of your data, and it also reduces data privacy risks as well. So that's where you can see the right side image where the trained models are then converted into TensorFlow Lite converters, so that they can actually have deployed onto your edge device like phone or Raspberry Pi, your smartphone, or maybe an Intel Edison or any other devices that we have right now in the market. Why ML on edge is really important, because we have to understand what the advantages of having your machine learning model running on the edge devices. So basically, whenever we develop machine learning applications, we have your machine learning model trained on some other tool. Maybe at this point of time we've been using Custom Vision from Microsoft, but we have a lot of other tools that are already there. So when you develop your trained model, you actually host it on a cloud to actually access that from your application. So that's where like it takes a lot of time in terms of processing your data, because it has to go back to your vendor specific cloud and then have a proper bandwidth in order to get these requests back. So, but if you have your machine learning model running on your edge devices, like somewhat like Raspberry Pi or other Odroid devices, so what it actually happens is the main advantage would be the processing of data locally would be really, really fast because your model is running on the device right now. The better application speed, where your application will be processing very quick in order to getting your request and putting it on your dashboards. That will be really speed, and it increases security for the devices and the data that's flowing in and out. And really important thing that for the enterprise or the CEOs, the CDOs would be it lowers the cost and then the lower network traffic because the entire machine learning model which is running on your edge doesn't reside on any other network because it's running right now on locally on your device. So it really doesn't care about the network that you want to have. And faster real-time predictions, that's really important for a kind of IoT applications right now. So coming to Custom Vision, so Custom Vision is a service from Microsoft. Microsoft is having a cognitive service that's called Custom Vision, and this Microsoft is helping us to actually train your images and then evaluate that by taking those images results from the dashboard itself. So they have SDKs as well, so you guys can actually go and try and play with those. You can actually upload images through the dashboard and then train it, and then have your model coming down. You can actually download the model and then host it on your edge devices and start programming using TensorFlow and OpenCV in order to access these models. So so they're actually providing a fast way to build, deploy, and improve an image classifier. So you can see on the screen like how the flow is going on. You can upload and then train and then evaluate your models as well. So that's all about Custom Vision. It's a free service from Microsoft. You can actually go and try. Coming to edge devices, so edge devices are slowly moving from CPUs to GPUs and then TPUs. So slowly they're getting smarter because whenever you're trying to play with your machine learning applications, you really need a really fast processing power and multiple cores in order to get your machine learning model executed or processed. So that's where initially we used to work with CPUs, which is like minimum cores and get optimized. Whenever you have your application running on CPU, it really takes multiple amount of days or even weeks to get your machine learning model to be processed. So that's where there comes the GPUs, which like thousands of smaller efficient cores helping us run the machine learning model in a multiple threads, so that the processing of data would be much faster when compared to a CPU. So it reduces from days to even like hours. So that's where the GPUs are coming up very fast in the market right now. And there's a new thing coming up from Google. It's like TPU, the tensor processing unit. We've been waiting for this. Google announced in the last conference, but still they say that this is improved 10x compared to your GPUs because this is mainly important for processing your model than getting your model trained. So we have to wait and see like how GPUs are going to work right now once they're in the market. So TensorFlow Lite or TensorFlow or OpenCV, these are all like the frameworks or the libraries that we've been using for developing our machine learning applications. So your application framework would be mainly depending upon like OpenCV and TensorFlow Lite, so that these embedded devices can actually process these things, get your models executed fast. So you can see the architecture right now. So what we have built. So if you can see on the left-hand side, we have this Custom Vision, which I spoke earlier in the slides about the Microsoft one, which is really helping us in terms of developing your machine learning models. So what we have done over here is we took couple of images, couple of objects like screws, bolts, nuts, wrenches, and all the inventory items, and we've been training that and trying to evaluate and get the accuracy for these models. And from there, we're actually bringing that model onto a blob storage, so that whenever there's a new model coming in or a new object got trained, so there will be a new version of model that's stored in a blob storage. And whenever there's a new model coming in, there's an Azure function which is actually triggering to your IoT Hub, so that it keeps on publishing that, saying that hey, there's a new model coming in, and that's where your edge devices actually have that model downloaded onto your edge device, like Raspberry Pi, so that it runs the machine learning model on your edge device. And once your model is there on your edge device, which is like the second part of the demo, the architecture, and you can see the load cell, which is basically measures the weight of your object in a very precise size, and gives out you very precise data, which is in like grams and kgs as well. And there's a camera on top of this load cell, which is actually taking the video frames of the objects that are placed on the load cell, so that it actually sends those images or the frames to your edge device, which is having your model running on, and then gives you the result on the left hand corner screen, saying that the classified image, whatever the image may be, it may be nuts or it may be a wrench or a screwdriver, and it gives the accuracy out there. So this is all at a very high level architecture, and I'm going to take you through a live demo, which is really cool, and understand how the inventory is being tracked and how the inventory is actually being identified by the machine learning algorithm, which is running on an edge device. So let's move on to the live demo.
Yeah, with that being said, let us quickly jump on to a quick demo that we have built on the inventory management. So if you can see here, I have a load cell which can measure the weight very precise, and I have a screen which actually gives out the results of the inventory that I'm telling you about in the previous slides. So I have an inventory of a few things which is related to hardware. I have a tester, wrench, and a cutter. So I'll just place on them on the load cell. So as I said, we have a machine learning model running on the Raspberry Pi. So it's just going to identify what the product is and what the weight of the product is. Before going into that, we thought of putting an authentication for this, so we just used RFID. And you can see here, this is an RFID, and I'm putting an RFID card just to authenticate myself. And it says welcome for me, and then it asks us to please place the weight. And if you can really focus on the screen, you can see there it's asking us to place the weight. So once I place the weight on the load cell, so the camera gets activated automatically when the weight cell is activated, and then sends out the video frames back to your machine learning model, which is running on your RPi. And then if you can see the screen, it says wrench, and the weight is like 10 grams and the quantity is 1. So this is all being processed right from the Raspberry Pi, and that's not connected to any network. So here the beauty that we wanted to showcase to customers or to the developers was the machine learning model is running on the edge networks, so it doesn't rely on any other network that is actually communicating to your cloud, because your model is not hosted on any cloud. So that's the main advantage, because if your machine learning model is running on a cloud, there are two disadvantages for us. One is this huge latency, and other thing would be you should have a proper bandwidth in order to request for your machine learning model. Let's go with another item. Let's go with tester. So I have another product I placed on the load cell, and it's going to capture and analyze. And once the frame is sent to that, so it's gonna give you the result on the screen. Yep, there you go. You can see screwdriver, and the weight is like 4 grams. So so I also have trained the model with few other devices as well. So there's nuts and bolts, cutter and all, but so everything we used over here is custom vision. So custom vision is really helping us in terms of classifying your objects, or maybe object detection is also there from the Microsoft service. And then we were able to identify these. This one is the last one. Let's see what the machine learning model is going to tell us. Most probably, yeah. There you go. It says cutter, and the weight is like 10 grams. So that's how we're actually running our machine learning model on the edge, and just wanted to showcase how the results are coming up and how the rapid speed over here. So with that being said, thank you. Have a great day.
Thank you for watching The Laboratory, a video series brought to you by Miracles Innovation Labs. For more on innovation, please visit miraclesoft.com/thelabs.